The Nobel Prize in Medicine was awarded on Monday to Katalin, Kariko and Weissman for discoveries that led to the development of mRNA vaccines, including those developed during the COVID-19 pandemic. It can be said that few Nobelists have had a greater share in saving lives than Kariko and Weissman. One study estimates that vaccines have prevented more than 3 million deaths and 18 million hospitalizations and saved more than 1 trillion in the United States alone. Of course, the worldwide impact was even greater. The most effective vaccines against COVID-19 so far have been mRNA vaccines developed by Pfizer Moderna, and both companies have benefited from Weissman Karikó's discoveries on how to alter the body's immune response to mRNA. Frankly, their Nobel Prize is richly deserved. This is also kind of a warning sign. In retrospect, few medical studies were more important than Karikó's work in Weissman's laboratory to make mRNA vaccines a reality. But at every stage, the research community that should have embraced this research instead stymied it because of science's strong incentives for more fundable and more publishable work. It is difficult to escape the impression that mRNA vaccines have reached production despite the system, rather than thanks to it. This raises the question: what other extraordinary world-changing research programs are our current research laboratory system ill-equipped to support? We almost missed this massive research series in 1989. Kariko was hired by the University of Pennsylvania in a role that would put him on track to become a tenured professor. However, she had difficulty obtaining grant funding for her work on mRNA. He was too invested in the promise of mRNA to move on to other projects that were perhaps more easily financed. David Scales, a junior researcher in his lab at Penn, told WBUR. And in roles like Karikó's, grant funding was everything. In 1995, Penn demoted him. Anyone with less courage and determination would have given up long before the foundations of today's vaccines were laid, Scales said. But Kariko persevered. At Penn, he had to jump from lab to lab, eventually joining Weissman's lab working on an HIV vaccine. Together, they were able to take a closer look at a key obstacle to creating mRNA vaccines: the body's strong immune response. mRNA. If the body recognizes it as a foreign agent and destroys it, mRNA will become unusable for vaccines. Together they found a way to change chemical bonds in mRNA in a way that allowed it to escape attention of immune system. An important scientific obstacle to the mRNA vaccine has been eliminated. But obstacles remained. A product of our broken academic science system. We couldn't get funding. We couldn't get publications. Pretty much everyone has given up on it. They tried working on mRNA vaccination outside academia, and founded a small company called RNARx. This too ran into problems in 2006. Penn applied for and received 2 patents for Karikó and We.